All right, so let's take a look at number 4. Because this is a little bit of a challenging one. So it says, what's the total number of diagonals in a 35-sided polygon? And so we're going to start by making a little chart. Sides, and I'm going to cheat here. I'm going to leave a space, and then I'm going to go diagonals. And we are going to try to come up with a formula by looking at smaller cases and then going up from there. So the lowest number they have on the page is the shape with 3 sides. How many diagonals does that have? 0. And then 4 sides has how many diagonals? Let me draw some shapes here. So here's a 3-sided one. Here's a 4-sided one. Here's 5-sided. Maybe one more one. That one. Oh, that's bad. Okay. So if I have 3 sides, then I don't have any diagonals because all of the vertices are consecutive, so there's none that I can draw. This one I can draw in 2 diagonals. And then 5 sides, I would get 1, 2, 3, 4, 5 diagonals. Is that right? Yes? Yeah. Okay. And then 6 sides. Can anybody make a guess? 9. And how did you get that? You did it. Okay. From 0 to 2 we go up by 2. From 2 to 5 we go up by 3. So Byron's guessing maybe from 5 to this one we go up by 4. And that would make 9. Let's see if he's right. So there's 1, 2, 3 from there. It's a bad shape to do. 1, 2, 3 from there. 1, 2, 3 from there, and then I need 1 more from there. So that is a total of 9. So we got that one right, okay? So this is one of those ones that we were working on yesterday a little bit where there is a pattern because it's going up by 2 and then up by 3 and then up by 4. But since it's not going up by the same amount each time, we have to do a little bit of extra work to figure out what the formula is. And so that's why I put in this other column and or row, and I tried to kind of get you to start thinking in this way yesterday when we were doing the handshake problem. What we want to do now is we want to look at the number of diagonals per vertex. So instead of looking at the total number, let's look at the number that are coming out of each part right here. Okay? All right, so obviously this one has 0. How many diagonals are coming out of each corner here? 1. And how many come out of each corner here? 2. And so that's nice because that is a very easy pattern. How many come out from each one right here? 3. Okay. So hopefully you guys can see that if the number of sides is some number n, how many diagonals per vertex am I going to get? What's the relationship between these and these? What? 3 less. 3 take away 3 is 0. 4 take away 3 is 1. 5 take away 3 is 2. 6 take away 3 is 3. So that's going to be 3 less, or n minus 3. All right? So now is the tough part. How do I take these two numbers and put them together to get these numbers right here? Is anybody, Lizzie, you, yeah? What? Excitement turned to, nope, okay. Byron?
Take the top numbers, times it by the middle numbers, and then divide by 2.
Okay, Rochelle, is that what you're going to say? Okay, yeah, good. And I sort of gave you that hint yesterday because that's what we did with the handshake problem, and so that's a good strategy to try. Once you make this middle row, multiply these two together and see if that will help you at all. So 3 times 0 is 0, so that would work for this one. But 4 times 1 is 4, and we want 2. So Byron said if you cut that in half, you'll get 2. 5 times 2 is 10, cut in half is 5, and 6 times 3 is 18, cut in half is 9. And so our formula appears to be that one right there. Okay? So very, very tricky. A lot of extra stuff that you have to do there to come up with that. But now that we have that formula, we can figure out the answer to their question. How many diagonals would you have in a 35-sided polygon? So I'm going to plug in 35 for n. And then 35 minus 3 is 32. Take that answer and divide by 2. I'm going to divide by 2 first, so I'm going to make that a 16. And then 35 times 16, just off the top of my head, is 560. Didn't look at my answer book to come up with that. Okay? All right? So that's tricky stuff. It's trickier than the other ones that we were doing because you have to throw in this extra row of information there that you kind of have to come up with on your own. So let's try a couple more and see if you can't start to get the hang of it a little bit. Okay, so number 5 says if you place 35 points on a piece of paper so that no 3 points are in a line, how many line segments are necessary to connect each point to the others? This one I think we could do by cheating. So points, and then what do we have? Segments. So 1, 2, 3, 4, 5. How many segments do we get with 1 point? 0. How many do we get with 2 points? 1. How many do we get with 3? And 4 is 1, 2, 3, 4 on the outside, and 2 in the middle makes 6. So we're going up by 1, up by 2, up by 3. Do you recognize these numbers? Yes? No? What? No? The difference is going up by 1 each time. Okay? What are these numbers here called? Do you remember? Triangular numbers. Yeah, this one is 1, this one is 3, and that one is 6, and so forth. Okay, so this is going to relate to the handshake problem that we did yesterday. What extra row can I add in here to help me figure out the pattern? Huh? In the last one we did diagonals per vertex. So how can we do something similar to that with this? Yeah. Okay, good. Let's go lines per point. Okay? So how many lines are coming out of this point here? 0. How many lines are coming out of each point there? 1. One going that way, one going that way. How about out of this point, and out of that point, and out of that point? 2. And then this one is going to be 3. Okay, so now we have found something that we can probably use because there's a nice easy pattern. How do these numbers here relate to these numbers here? They're going up by 1, so I'm going to have 1n, or you can just leave that as n if you would like. So I have 1, then what do I have to add or subtract? Right, subtract 1 each time. 1 minus 1 is 0, 2 minus 1 is 1, and so forth. Okay? So that gives us those numbers. Now, how can I guess I made my column in a funny place. I need to take the top row and the bottom row and multiply them together, because multiplying is kind of our trick. So 2 times 1 is 2, but I want 1. 3 times 2 is 6, but I want 3. Right, so I'm just going to end up taking these things and multiplying them together and dividing by 2. Okay? And hopefully that should work. So now we want to again figure it out for 35 points. They've got something with the number 35, don't they? So I'm going to plug 35 in there for n. So that becomes a 35, n minus 1 is now 34. That's divided by 2. And I'm sure you can all do that math in your head and get 595 in your answer. Okay? So do you see a pattern in the patterns that we're looking for? A little inception geometry going here, patterns within patterns. What are we doing every time that we're solving these problems with these numbers and these numbers? But to come up with this formula, I'm taking the n and the n minus 1 and I'm doing what to them? Multiplying and then dividing by 2. Same thing here. Took the n and the n minus 3, multiplied them and then divided by 2. So that's kind of something to keep in your back pocket in case you are stuck. Okay? So let's do one more. So once again, we're drawing lines on a piece of paper, and now we're counting their intersections. So lines, let's leave a blank just in case. We'll go intersections. Okay, so if I have one line, how many intersections do I have? 0. If I have 2 lines, how many times do they cross? Once. If I have 3 lines, they cross 3 times. If I have 4 lines, how many times would they cross then? I don't know, is it 6? Or is it, yeah, I guess it's 6 because none of them are parallel. Is that what it said? Right, so something like that. How many times does that cross? 6, is that what we wanted? It's not 4, oh, it's not 4 lines, okay. That's too many lines. Okay, so let's try this again. So here's a line here, and I'm going to draw another one like that. Then I'll draw another one that crosses both of those. And then do I have to draw a 4th line that crosses all 3 of those? Yeah, so like this, 1, 2, 3. What's that? Okay. 1, 2, 3, 4, 5, 6. Okay, so it still works out. Okay, well, guess what? 1, 2, 3, 4, 0, 1, 3, 6. 1, 2, 3, 4, 0, 1, 3, 6. Exact same pattern. So that means we're going to have the exact same formula, right? So how many times will those lines cross if we make 35 of them? 595. So that times the formula is exactly the same. All right? Okay, so number 7 says, look at the formulas you found in exercises 4 through 6 to describe how the formulas are related. What did we do each time? Multiplied and then divided by 2. Then explain how the 3 problems are related geometrically. Any bright ideas there? They all have triangles or shapes. They all are in lines and points. I don't know, however you want to do that. Okay. Okay, so now for 8 and 9, and I think maybe just 8 and 9 actually, we're going to try to figure out which one of the problems this one fits. So we have 40 houses in the community, and they all need direct lines to one another in order to have telephone service how many lines are necessary, okay? So again, we're going to start with a simpler situation. So if we have 2 houses, how many lines would they need to connect? 1. If we have 3 houses, how many lines do we need to connect, everybody? 3. And if we have 4 houses, then we would need 1, 2, 3, 4, 5, 6. So which one of the problems that we just did is that like? Is it like this one? No. No, because then you have a house in the middle with lines coming out. That's a weird thing. Is it like this one? Yes. Okay, so this is going to be the formula that we're going to use. N times n minus 1 divided by 2. And how many houses do we need? 40. So I need to know what 40 times 39 divided by 2 is. So that is 780. Okay? So now what you're trying to do is you sort of have some set formulas that you're going to need to come back to periodically and use to solve problems. And so now it's helpful if you can take a problem and recognize, is it a 0, 1, 3, 6 kind of thing? Or is it a, what was this one? 0, 2, 5, 9 sort of thing. Okay, so you can relate these back to some of the problems that we've done before. You can always do the models and do all the work and come up with the formula again, but this might be a little bit faster. All right, number 9, if each team in a 10-team league plays each of the other teams 4 times in a season, how many league games are played? All right, so once again, let's break this down into a smaller problem. How many teams should we start with? 10.
What?
Yeah, 2. Let's start with just 2 teams in our league. Okay, so we have teams. I'm going to leave a space because I'm not really sure where we're going with this here, and then this will be number of games. So if we have 2 teams, and everybody plays each other 4 times, how many games are we going to end up playing?
8.
8?
No.
No. Yeah?
No.
Somebody help. 4? Yeah, because there's only 2 teams, so we'll just play each other 4 times. Okay, so that'll be a total of 4. So in this case, the problem has changed a little bit because now each segment that you draw between 2 teams is actually worth 4. So there's 4 segments there. So now I'm going to have 3 teams. So these people play each other 4 times, these people play each other 4 times, they play each other 4 times. So how many games will there be altogether? 12. And if I have 4 teams, well, these all have to play, this guy's got to play everybody 4 times, right? And then this guy's got to play those 4 times, so it's 4 there, 4 there, and then add that one on there. So how many do we really have? What's that? Yeah, 24. Okay. So obviously we've got this little 4 thing going on. So this number right here is 4 times 1. This number right here is 4 times 3. And this number right here is 4 times 6. Okay? So I don't know if that helps. Let's go back and break it down into, losing Mariah again, games per team. How many games did each team play here? 4. How many games did each team play here? 8, because they played this one 4 times and that one 4 times. So they played a total of 8. How many games did each team play here? 12. Okay. So if this is my n, these numbers are going up by how much each time?
4.
4. So then I know from what we've talked about before that it's going to be 4 times n. What do I have to add or subtract to make it work? Minus 4, because 2 times 4 is 8, minus 4 is 4. 3 times 4 is 12, minus 4 is 8. 4 times 4 is 16, minus 4 is 12. So if I subtract 4 each time, then that will work. Okay? And then let's do our multiplication trick again and see if that helps us. 2 times 4 is 8. We wanted 4. 3 times 8 is 24. But we wanted 12. 4 times 12 is 48, but we wanted 24. What can I do to those things each time to get what I want? Divide by 2. So it's the exact same thing before. It's going to be n times 4n minus 4 divided by 2. So it's a little bit trickier because everybody's playing each other 4 times, but it's basically the same idea. And then what do I need to do to figure out how many games will be played if I have 10 teams? Put 10 in for n. I put a 10 there. 4 times 10 is 40, minus 4 is 36. 180. So 180 games total. Okay?
Number 10.
Okay, number 10 is a great question because it relates to what we did yesterday. It says each person at a party shook hands with everyone else exactly once. What is the formula we came up with yesterday for that situation? Anybody remember? What? Does anybody remember or have it in their notes? Rochelle, can you save us? Okay. Okay, good, thank you. Okay, so that tells us the number of handshakes you will have if you know how many people you have. But this question is asking the other way around. It says there end up being 66 handshakes. How many people were at the party? So instead of plugging 66 in for n this time, right, I have to set it equal to 66 and then solve that for n. So a little bit of algebra review here. What do I do to solve that for n? Okay, multiply both sides by 2. So n times n minus 1, is that 132? Okay. What? Never happened. Okay, now there is some algebra that we could do to figure this out. We could distribute the n and then maybe factor or quadratic equation or something like that. How about if we just guess the check? Okay, pick a number for n. Make a guess.
12.
12. Okay, so let's say that n is 12. Then 12 minus 1 is 11. Is 12 times 11 132?
Yeah.
Yes, what a terrific, yes, Kylina. So that means that there must have been 12 people at the party. Okay?
Are you sure it was a party?
Yes. It was a gathering. To get together. Yeah. Yes, we can do number 20. Number 20 is a little another pattern, and they're laying it out as they're calling this rectangular numbers. And so we can make a little chart right here again. I'm going to get really crazy though. So this is the figure, and this is the number of circles. Okay, so in figure 1 there were 2 circles, in figure 2 there were 9 circles, in figure 3 there were 20 circles, and I didn't draw it, but in figure 4 there were 35, right? Okay, what kind of a shape do we have here that we're getting the circles from? Rectangles. How do you find the area of a rectangle? Length times width. And so what I'm going to try is I'm going to make another couple of rows here for the length and for the width, okay? So I don't know which is length and which is width. What's the length of this first one? 2. Okay. What's the length of the next one? 3. What's the length? And that one's 4, and this one is 5. Okay. How do these numbers here in the length column match up with the figure number? They're one more. Yeah, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. So this is n plus 1. Okay? Now let's talk about the widths. So how far across these are. So this has a width of 1. This has a width of 3. This has a width of 5. And if you looked at the one in the book, that one would have a width of 7. So now we can use what we learned from Monday. Paige, you with me? Okay. What are these going up by each time? 2. So that means in my formula I need to have 2n. What do I have to add or subtract to make that match up? Minus 1 or plus 1? Okay, minus 1. Because if I go 2 times 2, I get 4. Take away 1 is 3. Okay? So, length times width. So if I want the total number of circles in there, what do I do with the length and the width? Multiply them, right, because you said the area of a rectangle is the length times the width. So my formula for the total number there is going to be the length, which is n plus 1, times the width, which is 2n minus 1. Okay? And so now we can use it to figure out what the 50th term is going to look like. So if I plug 50 in here for n, 50 plus 1 is 51. And then 2 times 50 take away 1 is 99. Multiply those together and you would get 5,049 circles. That is a lot of circles. I would not like to draw all of those. Right?
Can you still do it?
Huh?
Can you still draw them all for us?
No. Okay, so the only thing that you're left with are the 11 through 19 true, false. So just hang on to your paper and let me read you those. You can correct your own.